All right, hello everybody. This is Adam with FANUC Robotics again. Going to do just a quick little video here, talking a little bit about calling programs from a PLC. I'm going to cruise through real quick about getting your FANUC robot talking to an Allen Bradley PLC. That's not the core of this video, but it's something that I want to talk about just in case that's your first step. Some people are using hardwired 24-volt DC signals. Some people are using Ethernet signals. But in your PLC, your CompactLogix or ControlLogix, this is not for the Slick 500s or the MicroLogix. But if you have the Ethernet capabilities for CompactLogix, and if your robot has the Ethernet IP adapter option, you'll cruise right through. So what you're going to do on the PLC side is you're going to add a generic Ethernet module. I have one here called LRM8. Let me show you. When you create one, I just named it LRM8. You put in the address of the robot, which I'll show you how to set. And then here's the magic. The input, output, and configuration of the assembly instance. For all FANUC, it's 101, 151, and 100. Then this is arbitrary. This is whatever you need or want. However many words of 16 bits do you want? So on the robot side, pretty straightforward. Menu, setup, hostcom, TCP/IP. On this line here, you'll type in the IP address that you want your robot to live on. Then you'll hit the next key and you'll initialize. When you click initialize, you'll get a little love note that says port has been initialized successfully. Then you'll be able to ping the robot, ping the controller. So that's for the IP. Again, just cruising through this because it's not the topic of this video. But then in your I/O and your Ethernet IP, you'll see this connection right here going to be true and online. If you need to change the size of this, you go to your configuration, make sure that your words are 4 and 4. They should just match whatever you want. Maybe you want 2 and 2, or you need 6 or 8, or however many you need. Just make sure that those match. Then turn that back to true, and when it's true, you'll see this go to a running status. So that's real quick, just getting IPs set, instances size set. What you'll see then is Logix will build controller tags for you automatically with the name that you gave it. So mine will say LRM8 input data, and it'll have words 0, 1, 2, 3. And then within each word, there's 0 to 15, so 16 bits of Boolean, so 1 or 0 value. So I'll have all these, 16 times 4, I'll have 64 bits of input, and you'll see them here, 64 bits of output. And that's what we'll be using for handshaking, program calls, passing integer values, because an integer is, right here you see, an integer is just a sum of bits. So once you have this set up, it's all just mapping, and it's pretty easy and straightforward. The next important thing to note also is when you're setting up your I/O, for example, my digital inputs, you've got digital inputs and outputs, user inputs and outputs, things like that. The one thing that is important here to note is that your config, the magic number for Ethernet IP, see Ethernet, rack 89, slot 1, start 1. When you map things to rack 89, it tells the robot to look at Ethernet for the I/O. Some of your robots from the factory will have maybe it'll say rack 48. That's the onboard I/O that's built into LRM8s and SCARA and things like that. So we use different racks for different things. In this example, I have 8 bits of inputs at rack 89. I could have made that 64 since the PLC is set to 64, but doesn't really matter. 89 is the magic number for Ethernet. If you're not using Ethernet, ignore everything I just said. So some other general housekeeping things, just to really let you know. You'll notice in the UOP, User Operator Panel screen, for our user inputs and user outputs, some basic things the robot is trying to tell you. Am I faulted? Is the teach pendant enabled or not? Am I low on battery? Am I busy? But things you need to tell the robot. If you're running a robot from a PLC, there are 4 bits that you will always need to hold on. It's because they're active low. So the immediate stop, the hold, the safe speed, and the enable, these UI 1, 2, 3, and 8 always have to be on if you want this robot to run. If you want to pause your robot from the PLC, then you're going to drop the hold signal. If you make that go low, then the robot will pause. You make it go high, then you got to resend a start signal. So always hold those 4 on. Then when you want it to run, you just bop that start signal for a handful of milliseconds. The robot scans at 8 millisecond ITP, so if you hold it for a quarter second, that's way more than long enough. So some other things to look at, just so we know how they work and what they mean, especially as it correlates to the user inputs. In our system config screen, you'll see line 7, enable UI signals. This is what I was just talking about, the user input signals for hold, start, stop, reset. If you want those to work, this better be at true. And then if you scroll down in this screen, scroll down quite a ways down to the remote and local setup. Right here, remote, I'm going to actually put that at remote. Remote means, hey, I'm looking for a PLC to give me my signals. Local means, hey, I'm looking at the buttons on my controller cabinet. So if you want to start and stop and pause your robot from the controller cabinet UOP, you use local. If you want to use a PLC, you use remote. So we'll leave that here for now. That's something that you want, and it does correlate directly to these UI signals and to the mapping that we just said. So that's important. Moving forward a little bit, let's start jumping into how we're going to call programs. Okay, so at this point in the game, I'm going to just assume that you have set up your DIs and DOs and UIs and UOs. You've got IP addresses talking. Life is good. I'm also going to assume that maybe you have some programs. For me, I made some quick, dummy little programs that don't do much. I made a circle path, a horizontal path, and a vertical path. Just some dummy points that I taught. So let's assume that you have some programs. Let's assume you've got your IPs working. Now we want to call these programs from your PLC, which is the meat and potatoes of this video. I'll put the asterisk on this, that what I'm about to show you is not the end-all perfect golden way to do it. It's just a way that I have been really successful in the past. Customers have been successful in the past. People seem to like it. What I like to do is go into my setup, program select, and from the factory, you'll probably see these set up as PNS, the program number select, or the RSR, run service request. I like to set this one as other, and the start method you might have seen as UOP, waiting for someone to hit the green button on the panel. I like to set it as other. So other and other. In order for these changes to take effect, you'll have to cycle power on the robot. Same as when you were configuring your IOs in these configs. Whenever you change these, you have to cycle power to save the changes. Menu, setup, program. Set these to other and other, cycle power, and then we'll come back in here in a minute. Now I'll show you two good ways that I like to call these programs. So let's create a program, and I'm going to call it main. Okay. Here's what I like to do. And again, if you've got a better way, that's totally fine. This is just what I like. Let me put a few lines of code in here, a few blank lines of code. We're going to first create a loop, an infinite loop. You can name this start or something like that. And I'm going to make a jump label 1. Okay, so now we know that when the main program starts, it's just going to keep jumping to label 1, goes to label 1. So we've got a forever loop right here. Okay, so here's method number 1 of the two methods I'm going to show you for calling programs. Let's take a if statement, and I'm going to use this very top one, this pre-built one, and I'm going to say if digital input number 1 comes on, I want you to call this program horizontal. So if you just take a look real quick at what this program is doing, it's just looping over and over and over and over and over, waiting for digital input 1 to come on. If digital input 1 never comes on, then we never call horizontal, and it just keeps waiting and waiting and waiting and waiting in this forever loop. So it just sits there and waits. Let's take that. Let's copy this logic, and let's say paste, paste. Let's expand on our idea here. Perfect. So now we're in this infinite loop waiting for the PLC to give me one of 3 signals and just say, hey, as soon as I get one of these signals, go do that thing. So let's test this real quick. I'm going to split my display so that we can see the IOs. You notice that over here I'm simulating the inputs from the factory. They're unsimulated, which means they're waiting for a PLC. Well, I don't have a PLC here at my office, so I'm just going to simulate these and fake it. You know, you can even do some things here too, as far as let's go detail. You can name these, you know, program 1, you know, next point, program 2, next point, program 3. And you can see now that as I added the comments for program 1, 2, and 3, it went right into my code. So now my code is self-documenting. If digital input 1, program 1 comes on, call horizontal. Now the way FANUC works, it's, you know, like stack programming. So if digital input 1 comes on, the robot's going to jump in to horizontal. It's going to run my horizontal path, and then it's going to jump back to where it was. So it'll go in, do its thing, and then come back. And then, so it's always going to either be in this loop or it's going to be in one of these programs. So let's test this theory real quick. Okay. So I'm going to start my program. So right now, this is what I want you to notice, and this is kind of nice. The robot is ready to pounce. It's busy, it's running, it's in the main program, and you don't see it looping, but it's busy and running. It's just waiting for something to happen. So if I come in here and just pulse that bit, you saw I just pulsed it, just went on and then off, and it runs the horizontal program. Let me pulse bit 2. There's the vertical program. Pulse it again. You can even see on the left of the screen it jumps into the vertical program and jumps back out. Let's run the circle. There it goes. Run it again. Now, the reason I'm pulsing these is because when you're in an infinite loop, it'll just keep running if you maintain the signal from your PLC. So on the PLC side, if I turn that on and just leave it on, it's just going to keep running that program over and over and over until that signal is gone. Same here. If I just leave it on, now it's just running vertical, off. But you can see how when it's called, if I just turn it on and then off, just a little blip of a signal, steps right through the program and does its thing. So that's pretty easy, pretty straightforward. That is the first method that I wanted to show you. So really, really easy right there. Take a screenshot, take it to heart, because I'm about to delete it and show you another method. So let me turn on my teach pendant. I'm going to delete all these. Okay. So the next method, it's very similar to the first, but I'm going to call it slightly more efficient, because in this first way that I showed you, it's one digital input per program that you need to run. So if you have 10 programs, you would be chewing up 10 digital inputs. That's fine if you're running Ethernet, because you can set up thousands, but if you're running hardwired, you can run out real fast. So what sometimes I like to do if I have limited numbers of digital inputs available is we start using binary. Because with binary, I can use 2 bits to call up to, 1, 2, 3 programs. 3 bits will call 7 programs, and 4 bits would call up to 15 programs. So I can call a lot more programs by generating combinations of bits. But FANUC makes it even easier than that. It makes it one step easier. Let me go get this all on the screen here. So if I go to my IOs, you'll see one in here called group. A group IO, this is group out, I'm going to go to input. Group input, let's look at the config of this. I've mapped group input number 1 to be rack 89, which you'll remember is Ethernet, slot 1, start 1, and how many bits do I want? Well, right now I only have it set to 2 because I only have 3 programs. So I can either have a 0, 1, a 1, 0, or a 1, 1. So I can call up to those 3 different programs with just 2 bits. But I set up my group input like this, cycle power to save it. And again, hey, right now I got to have it simulated because I don't have a PLC running. But I can set my value. Now, let's take a look at what we can do with that in the program. I'm going to make a numerical register called program, R1. And in my main program, instead of using the if, I'm going to use the select, which is right here, select R. So I'm going to say select R1 program. And I'm going to say if the program equals 1, call horizontal. Okay. Then select over here. I'm going to use this one, the one right below the main, because I'm going to amend to that. I'm going to say else if it equals a 2, call vertical. Else if it's a 3, call circle. So now I've got this nice little setup that says, hey, select based on the R value. If it's a 1, call horizontal. If it's a 2, call vertical. If it's a 3, call circle. The one part that we have to add here, the secret sauce to making this work, is a line of code that says register 1 equals, because we got to know what register 1 is, it's coming from group input number 1. So it's just that simple. And I can do some housekeeping here and clean that up a little bit. Maybe even put a space here so it's easier to read. So here's our infinite loop. Every time our loop starts, it's going to take whatever is in group input 1 and dump it to R1. So it's going to update every scan. So every scan it's going to say, hey, what's the PLC sending me? Put it in R1. And then the select statement is going to look at R1 and it's going to call the appropriate program. So if we go like this, I'm going to do a triple screen. We're going to look at our group inputs right here. We're going to look at our registers, and what should happen is while this is running, I'm going to simulate a number coming into GI1. We should see it auto-populate into R1, and then we should see the robot run the appropriate program. Should. So here we go. Let's call our main program, run it. Okay, so the main program is busy and running. It's sitting there. There's no value in GI1, so the robot doesn't know what to do, but let's put a 1 in here. And there it goes. So as it's got a 1 in, a 1 is going to R1, and it's calling that program. As soon as I put that back to a 0, it quits running. Remember how it's sustained. So if I do a 2, there's my vertical, 0. Put in a 3, program 3, 0. So again, if I was a PLC and I could do it fast, I'd pulse it. So let me do like a 1, 0. There we go. So I can just pulse it real quick, 2, 0. So you send that number just as a quick little quarter-second pulse to the robot, and it's just going to take off and run whatever it needs to run. So right there, that's method number 2. I'll go ahead and stop the robot now. The final trick, I think I did in fact skip over this, so hopefully you're still watching the video. Under the program select, we changed these to other and other, you remember? Inside this other, there's a detail, shell work custom name. If I choose main right there, then that means whenever the robot sends us the UOP for start, the main program will automatically start. So remember, the PLC is already holding on these 4 important ones. Whenever it pulses UI6, you just have to pulse it. UI6 is going to send the start signal to this, which is defined as, detail, as main, which means it's going to run the main program, which puts it in the infinite loop, which looks at our inputs. So hopefully that helps everybody. And if you have any more questions, feel free to contact FANUC at 888-FANUC-US. Or hey, put some notes in the comment section of this video, and maybe you'll inspire my next tutorial. Thanks, guys.